Okay. Hi, everyone. We are up. Uh, Vladimir, if you could turn on your camera. Hi, everyone, and welcome to today's session. First of all, I'd like to thank you all for joining us as we are getting closer to wrapping up an exciting year for the blockchain professionals community. And as the holiday season approaches, I want to take a moment to congratulate all of you on the upcoming holidays. I hope you're having fun. Your energy, insights, and enthusiasm have been a driving force for the blockchain professionals community, and I'm truly grateful to have you all here. Today, we're diving into exciting topic, how to use CLI for deployment, with two amazing speakers and good friends of our community from Power DCloud, Vladimir Goncharov and Dima Burov. They'll be walking us through how CLI tools can simplify decentralized deployments, deploy smart contracts, etc., etc., etc. So I'll pass the floor to Dima and Vladimir. Maybe you could tell us a little bit more about you, so the newbies in our community know where you guys coming from and find out more about your backgrounds.
Hello, everyone. My name is Dima. I'm Chief of Product of Power DCloud. With me, Vladimir, CTO. And today I will talk about using of CLI for Web3 needs and so on. And before we will start, we will explain what we are doing. We are building Power DCloud. Power DCloud is the PIN network is based on EVM, and it's focused to make alternative for centralized cloud, centralized services, because on the current market stage, everyone needs to use, for example, AWS, Google Cloud, or some other kind of services for distributing and deploying the apps, and we build Power DCloud. Our major focus in providing application chains. It's based on EVM, and it's compatible with all EVM stuff. And we'll see how it's working today on some popular tooling, for example, Foundry, maybe. And also we use inside Docker engine, and we will show how to deploy Docker containers to
Dima, could you please turn your mic back on? Thank you.
Do you hear me?
Yes.
Great. We are focusing on providing, as I explained, infrastructure side, and we will see how to use CLI for these needs. Our platform based on full sharded protocol, and we provide each shard like application-specific chain, like a tailored blockchain environment, and you can use it, for example, for L2 solution or for scaling Ethereum. Any other EVM networks, and you connect providers like a storage provider, compute provider, CPU, GPU. It's only different on hardware side. And we aggregate computer power from our community. We have several tiers: community tier and enterprise tier, where we're working with micro data centers, and you can find pretty good quality of resources. And in total, we are trying to simplify the current stack, because on the current market stage it's too complicated, and some tools like CLI and other tooling is help to and simplify usage. Yeah. And let's switch to presentation of how to use CLI. Yeah, thank you. And on today's session, we'll showcase how to use CLI. It's enable you to manage accounts, for example, blockchain accounts, deploy smart contracts, and create decentralized containers efficiency. And my colleague Vladimir will handle as a live demonstration some cases. And before we will go, why use CLI? His answer is efficiency and control. When you use CLI, for example, instead of some complex web interfaces or something like that, you can control all stage of deployment process, and in some cases it can be more simple than using the complex tooling, but for super big complex cases, of course, you need something bigger than usual CLI, and so on. It helps to automate a lot of tasks. For example, start, create containers, stop containers, updating it, and run the task efficiency, and so on. And you can follow some instruction in parallel, or you can try to repeat if you want in parallel. To install CLI, you can use npm, and when you will use it, it works with several environments: DevNet, testnet, or AppChains. Soon we will add several more networks. And the basic features is then you start its account management. You can use several commands, and also it's possible to use autocomplete, for example, for ZSH, and it help you to manage it more efficiency. And for example, you can use for checking the balances. You can encrypt your account with password, and you don't need to save the key in like an open key on your disk, and so on. And the three basic features of CLI is smart contracts management, storage management, and container management. For example, you can use it for deploying smart contracts. For deploying smart contracts, you have to attach, for example, AB file and binary file. You can build your smart contracts with any tool, but basic tool is usually Solc, and you can compile it and touch a couple of files and deploy it. And it also it has get and set commands, and you can, for example, mint some tokens for your address or for other needs directly from CLI, and it's pretty convenient. Yeah, for example, for container management, you can use several commands. We will see today how it's working, but usually it's for creating the containers. You can upload, container start, stop, and some usual Docker commands, but for interacting with decentralized network, you are using CLI, and it helps to make more efficiency. Yeah, well, let's show a couple of first cases, how to create account and what will be how it's working. One second, please. And
That's we have a question from the audience at this point. Do you mind taking a
okay.
glance at one question from the VR community? So someone is asking what inspired Power DCloud and how CLI tools became such an integral part of Power DCloud's vision.
Okay. When we start, we have a fully unique protocol with own consensus and so on, and we need some tooling to manage it on the first days. And in parallel, we add compatibility with all EVM stuff on ABI level and also on ATH-RPC level, and you can use, for example, Block Scout, Foundry, Hard Hat, on any other EVM tools, for example, Safe Wallet to manage multi-sign. And so on. In our vision, it helped to why we use blockchain under the hood. It helped to manage all our nodes in fully decentralized way. The management is working over smart contracts layer, for example, register provider, provide some resources for some people who need this and for deploying. And also you can bring your resources and touch it like provider, or you can use it from other side. It's like a marketplace.
Thank you, Dima, for the time.
Yeah, and a last couple of thoughts. It helped to make the pricing super efficient because, for example, in parallel, if we compare with some centralized providers, for example, AWS and Amazon have to maintain own infrastructure, and they have to spend a lot of money for maintaining it. In our case, we are building something like Uber for computer resources, and everyone can bring it from local to global market, something like that.
This is a good point for the people from the enterprise. I hope you guys are watching us and got this key takeaway. And we'll come back to the questions on business also. But for now, I think we were transitioning to the demonstrational part, right, Dima?
Yep.
Okay.
Okay, let's start from registering new address. Our blockchain is a little bit different from normal UAM. It designed by like a corporate blockchain, so it has different addressation, but it also supports EVM addresses. And so if we deploy some contract to address to Power address contract, we have to register address before, and then we can deploy contract in the address, and after we have to delete keys from account. So it we can have EOA with deployed smart contract, yes, and it can be used. So we have to start from start. We have to register some address, and we can use TP CLI interface for it. It has help and also you can install after completions for your favorite shell. We can start from TP register. We choose a DevNet and chain number 3 as for now, as for today. Okay, we have address, and this is a private key, seed phrase for it, and address will select this, will look like this. First of all, we will deploy ERC20 token. We have a two-way for deploying it. One way it's using Power Tools and Power Interface, and other way is using EVM compatible RPC. So we can use, for example, MetaMask. We can use Hard for deployment, Foundry, and even Remix. But today we will try to deploy contract in a Power way, and maybe a little bit later I will show you how to deploy with Foundry. So we have a very simple smart contract. It's ERC20 token with free for everybody mint or here with unrestricted mint and burn for testing. We can clone this repo. And go here. So we can compile it with just SolCJS without huge tools. And we get binary and ABI file. Now we have to register maybe one more address for contract. We can deploy in the same address. So TP contract deploy. Here I choose ABI file, B binary file, key file, it's Power Wallet, and also I have to specify arguments. For example, my token 1.
And you need faucet also.
I will explain. It's 3 arguments for constructor. If we look to my token soul, we have we see here constructor. It requires 3 arguments: name, symbol, and decimals. So token name will be my token. Symbol will be MTK1, and decimals will be 8. I forget. We have to get some tokens for test. And we go to faucet the Power IO. Select testnet chain 3, pass our address, and okay, it's done. Okay, we're ready to deploy contract. Let's try. Okay, it's done. Now we can actually check it and convert this address to, for example, this address to Ethereum format, and can apply it to MetaMask MTK1 Okay, next we have 0. Let's try to mint anything. We can use TP contract set for sending commands to, like, sending transactions to smart contract. My token, so token ABI. We have to specify address. Here it is. And mint. It's a method mint. And params. Let's look smart contract mint. First argument address and second argument amount. I will copy my address and amount. For example, I want 1, 2, 3. And as we specified decimals 18, so I have to add 18 zeros here to have 1, 2, and 123 tokens. Oh, I forgot to specify key file. Wow. I didn't have a password here. Now wait a moment, let's look again. Looks like something went wrong. No. Why tasks? Password. Account key file password. API address. Password. Oh, R instead of P. Yeah. Okay. So we have to get some tokens very soon. We actually can. We have to wait a little bit while MetaMask refresh balance. We can check it while waiting.
We have some questions from the chat.
Oh, okay.
Vladimir, we could take a look at them.
Okay.
Yeah, I will answer. Yes, you can customize and you can launch your own app chain, and also you can add the chain to list. We have a private and public list. Public list is available on our GitHub, and you can, when you launch your app chain, you can add it or fork it. It's your own way.
Okay, so we have 123 tokens, and we can send it, of course. For example, 23 tokens. Okay. Okay. And now we can, for demonstration, I will deploy one monitoring Telegram bot for monitoring contract, and we try. I sent 23 to my other account, and it's already here. Now let's try to deploy Telegram bot for monitoring ERC20 token. In
Vova, also, it will be great if you explain what is binary and what is AVI files and
okay,
why we need both.
Okay. We have source file in Solidity, and after compilation, we have two files. It's a binary file that represent code of a contract, and also we have ABI file. It's a JSON file. It's a JSON file that specifies a binary interface of the contract. Here we can see all functions. It's a constructor. For example, this is event. In case of approval, we have we will receive this event with this. I'm sorry, with these arguments. So any application that wants to communicate with the contract have to have ABI file, and so application would be able to make correct binary for request, and also be able to interpret, like decode a response of the smart contract. And a binary file, it's like it's just not this. I'm sorry. It's just a hex file.
Yeah, ABI is like a declaration of what
Of
you have inside of. Instead of using of API in general in web3 way, you have to use application binary interface, and ABI it's explain or feels it's like a mapping. You can compare it. Yeah. Okay, let's go to the container pass.
And let's look for container. Okay, we have a simple example of bot written in Python. It will connect to Telegram, and also it will be pulling Ethereum RPC provider every 30 seconds. When it get some event from a specified contract, it will notify users who subscribe to the address. Let's try to clone this repo. We have to specify some parameters for the application. First of all, we have to have Telegram token. It's easy to get it using bot father in Telegram. I can show you how I did it a few minutes ago. I just sent start command, new bot. I choose the name from the second try, and I got a Telegram token and name for the bot, and let's try to. I will be using the same token as before created. ERC20 token address. We will use just deployed my token 1. I use this address and a Ethereum RPC URL. I will be using our testnet chain 3. So I have a prepared No, I don't have prepared. Okay, this is our RPC. Okay, let's check. We have a compose file. Here we describe our service, what environment we need to set for it, what volume we use, and we will build it on server. Here we have a Docker file. It will be using Alpine with Python, install few requirements, and run appy.
You can check the address. Probably you have a typo.
Where?
In the address. Mm-hmm. Yes, the last symbol. E.
Huh?
E. In the address.
No, it's okay. It's okay.
Okay.
Yeah, we can check it by, for example, using our API. Yes, it's a correct address.
Yes. Yeah. You can show also some endpoints of API. Also, it will be useful.
Yeah. We can, for example, view in a very convenient JSON way our address, balance. We see deployed code, last block, public key of address, and address itself in two formats, in a hex format and a text format. In our application, we in the interfaces we mostly using text address format, but as we have a EVM compatibility, so we using two address formats because we have to have to be compatible with Ethereum. Okay,
and also
now,
each node has its own API. Each node has SSL, and you can use it like a decentralized HTTPS RPC provider, each node. And thanks to multi-master consensus, each node has the same state of data on each node, and it very useful and bring instant finality.
Yeah, the data applied simultaneously on all nodes after reaching consensus of consensus about block. So block prepared, and after reaching consensus, it applied to all validators simultaneously, and that's why we have our transaction finalized in one block. So if we have our transaction in our transaction in block n, if we have block n plus 1, the next block, then it's already finalized. No need to wait 6 or more confirmations.
Like on Ethereum, Polygon,
Yeah.
or any other consensus with leaders.
We have a possibility to roll back only one block so it can be forked only for one block, not more. Okay,
And you can configure the time of block. For example, 1 second, 10 seconds. It's up to you.
Okay, we have prepared a repo, and now we have to make a container. Container create key file. Key power value. This will be using the same. Container name. Dima bot. I think it's enough. Okay, now we just create a container. It's we just created a record in a smart contract, not more. And now we have to upload our data to some of providers who participate in this contract, in this specific contract. At a chain number 3, we have a deployed contract with only one provider for test, and we will try to upload our container there. We have it's important that we have a container ID. We have to specify it every time we have to upload or stop or start container, because each address can have multiple containers, and so to specify which one you want to stop or start or upload, you have to specify number each time. So we have to upload container, and let's look what it requires. We have to specify key, number 7, container key file. Every time you create container, for each container, automatically our utility automatically generate new key file for container, so you don't have to use your private key from blockchain to manage your container. You need it only for creating. After you will be using other key that unique for each container. Yeah, for interacting with providers RPC. And we can specify path for the example TG port ERC20. Okay. Now it will try to ask me which provider I would like. We have only one provider. On first upload, provider tries to acquire this container to themselves, and sometimes if it takes too long, we can get a error at 307. We have to try again, and it should be okay. It uploads. Okay, it uploaded. Now we have to start a container. We can use container actions for it. Yes. What is wrong? Container. Container. Yeah. Actions. Method container start. Actually, we have a some kind of manual in repository, so we can look here and do as in readme. Container start minus I. We have to specify this number 7. And we have to specify params the same. Yep. And we need to specify yes, a key for controlling container. We don't need to blockchain keys anymore. And we try
only with owner of the key can has access or manage its container. Without it, if you will lose it, you can manage it, and nobody can control without this key.
But actually, a owner of owner of private key of address of blockchain address can stop container to avoid charging. It can terminate container in smart contract. So provider will have to terminate running instance. Okay. We deployed bot, and let's look if it works. And we have
anyway, we prepare for you another example. You can check it after. All repos available on GitHub, and case with C compiler, and also with Foundry, and we will check how you can use another tooling like Foundry. You can use Hot, as I already said. Some additional tools also should work.
Now we will be using Foundry. It's a tool for regular EVM chains. You can use Foundry for deploying any EVM chains, and also at Power Chain too. So first of all, we have to create EVM address. I will be using a Foundry tool, a cast for it, and it's generate key pair. This will be my private key for deploying contract, and this will be my address. I need some tokens for deploy anything. Okay, let's try to deploy ERC20 token. I have to specify private key for deploying, and we have a deploy script that will be run this script. It will be creating token. Specify name, for example, my token 2, mtk 2, and I also can mint some coins to get it instantly without extra command, but I will show you how to mint it too. And deploy.
Also, Foundry has a Sol-C compiler inside, but here you have huge functionality. If you have some big project, for example, Uniswap, I don't know, you have to deploy with some advanced tooling like Foundry, because it's a set of smart contracts, and for deploying with tools like Foundry or Hot Hat, you have to prepare some deploy scripts additionally. When you use CLI, you can control it with each command, get, set, and so on.
Okay, so we have deployed our smart contract. We have this address, and we have two hashes of transactions, because we have a first transaction deployed a token, and second transaction minted some tokens for me. And I will try to add it to MetaMask and look if it works. MTK2. Okay, I have some tokens. If on another account, I also imported this address and would not have tokens. I have 0 here. And let's try to reconfigure a bot. I forget. Here we generated a private key with cast valid and exported a private key, but actually we have to save it. Today for demo I would not save it, but actually you have to save this. In TPE utility, all private keys generated saved to files automatically, but if in case of Foundry, you have to do it yourself. Don't forget. Okay, contract address, and we will try to fix our bot. And file. Let's try with this address.
Also check as Telegram token for.
I'm sure token is okay. And I also rename it once again to be able that a provider rebuild my container. Actually this time I don't need it. Yeah, I just changed end file. Okay, try to upload it again. This utility should be able to upload only one file, but I'm not sure how to do it right now. Okay, let's start it and look if it works.
For uploading your container, you can use only Docker Compose file. It will be enough for starting your container. or you can
Okay,
use
let's check. Okay.
the
Okay,
whole
let's
folder, like in our example today.
let's try again. The bot saves monitoring addresses for monitoring to JSON file, but I try to set address again to avoid possible problems. Okay, I don't have here tokens, and let's try to send oh, it works. Transaction detected from this address, value 10, current balance 10 tokens. Okay, let's check. Yeah. Yeah, it's 10 tokens. So I think it's it was some incompatibility with Python library with short addresses. Okay.
But it works,
Yeah, it works.
yesterday.
It worked yesterday. Yeah. That's all I wanted to show you today.
Yeah.
I think,
we'll share you this presentation. Here you can find some basic commands, some basic examples that Vladimir showed you today, how to deploy, how to form all keys, all paths, and so on. And also here is for repository, one of them with container and Python bot, another one with ERC20 for Sol C compiler, and one with config for Foundry. And all documentation for CLI you can find here, or also you can read it in npm repo, or you can use help commands. It help you to manage it faster. And yeah, I think if you have some questions, let's go ahead and make it more interactive.
Thank you so much, team, for the great demonstration and troubleshooting with us today. It was very valuable and insightful. I think we've got some people from the enterprise, and who goes the following question. Could you share examples of industries or projects that are already using Power DCloud for tasks like smart contracts, containers, or workflow automations?
Okay. Can we switch for initial presentation? There I have a couple of slides. It's a little different, but it helped to explain some examples. What is the basic solution that project use with our platform? They use app chains with EVM inside, with own customizable token economy. They can control level of decentralization, how many nodes can participate in consensus, like block producers, like seed nodes for distributing content. And as we mentioned during the demonstration, each node has their own decentralized HTTPS API. You can open JSON file directly in browsers and so on, and you don't need to maintain some intermediaries. It helps to bring real decentralization for projects where it's need, for example, DAOs, decentralized exchanges, and so on. Some users build for right now it's super popular social file applications where you have a user interface and this interface is stored in decentralized storage uploaded from the nodes, and the nodes work like a CDN and like edge network in distributed the closest data for your users to bring speed and caching, so on. Also, some middle whereas people usually deploy for container nodes, and also you can use liquidity bridges to any EVM networks, for example, BNB chain or Ethereum mainnet. And your users can bring liquidity directly from other networks to app-chain and on user account, and you don't need to maintain your liquidity pools, or you can form own liquidity pool with user liquidity. And it's a typical case. For example, you have a storage, blockchain nodes, Docker nodes, and right now we exploring the cases with AI engines because you can deploy container nodes on GPU shards and run some simple microservices for AI agents. You can use external APIs like OpenAI, or you can deploy your own small llama, or maybe you have a own servers, and also possible to connect and so on. And how to form upchain. I think we can skip it today. If it will be interested, we can make another webinar for how to launch your upchain and how to manage it and so on. It's more. It's take a little more time than today, but yeah. Next questions. For someone just give us with some simple use case and understanding to capabilities. For super simple use case, you can use a repository that we show today. The super simple case is ERC20 tokens because you can deploy it. You can add for your wallet, you can send transactions, and you will see the balances changed. And from other side, you can connect container with monitoring, and you will see how balances is changed. It's something like hello world of Web3 infrastructure. Also, we can make a post for you and send some popular tooling in EVM world. On Web3 market, we have two fields, for example. One is EVM compatible. EVM is Ethereum virtual machine. Right now, it's available on a lot of chains is something like market standard. Right now, more than half of the market use only EVM, and also for EVM available several different languages. The most popular is Solidity. It's close to ECMAScript narratives, and from other side, for example, you can use Viper language. Viper is inspired by Python. If you it depends what you
Viper
familiar
is
right now.
actually Python. Just
Yeah.
it compiled to EVM code.
How does Power DCloud compare with other tools, term, speed, cost, efficiency? Okay. Why we use Power CLI and maintain it? Because right now available other tooling on the market, and for example, for smart contracts, you can use Foundry, Hot Hat, as you mentioned, as is too super popular before on the market.
And even
available.
Remix.
And even Remix, yeah.
Even Remix, web-based IDE with compiler and debugger to develop smart contracts. But today's topic is CLI, so today we deployed with CLI.
Yeah, and available different tools. You can choose it. What do you like? But Power CLI has additional features like storage management, container management. Other blockchain platform can provide you this kind of solution. Only smart contracts, and that's all. And we are building something like decentralized cloud, where you can find some other different services, and our focus to bring the platform where you can build full stack application in the same place in the single infrastructure. And you don't need to combine like a function string from different pieces. It's very popular right now. What do you it depends. You can raise the question. What would you say to John? He said to try decentralized solution because they are comfortable with traditional cloud services. It depends what kind of application you are building. If you build some application for government, of course, you can use, for example, AWS and with some special regions. If you build some new projects, you can use modern cloud, not only because in the cloud field, we can split it for several grades. For example, super big traditional clouds, it's like AWS, Google Clouds, Azure. In the middle term, we have a next gen cloud, for example, Vercel, Netlify company. It's a cloud with some additional tooling like CI/CD. And in our case, we are trying to build something similar, but with computer power from the market. And it helps to make more efficient pricing, efficient performance, make it available for all people. And it depends on what you are looking. If you need to deploy, for example, Kubernetes, I think you need to choose centralized cloud, or you can find a couple of web-free platform who focused on providing Kubernetes, but it's not working decentralized way. Of course, it's like just a marketplace based on smart contracts, something like that. In our case, we are focusing on providing the platform like a service, for example. Okay, next question. If you want to test small particular use case today, what will be easier to get started with CLI tool? As I mentioned, try to follow our examples, and it's helped you to make the initial steps. try to build and deploy with CLI. You have a control, and you can learn, can understand how it's working, and so on. If you will go from the first days, for example, to Foundry, hard hat, probably it will be a little complicated for you because it has additional features. For example, for testing smart contracts, you can run, for example, hard hat can launch your local EVM network. You can develop with own local environment and so on. But for our CLI is focused only on managing account, containers, storage, and smart contracts, the basic things. And you can use just as compilers like Solc. You don't need to use Foundry and so on.
Okay. I think we ran out of the questions for today. And we're almost up in terms of the time. Dima, Vladimir, thank you so much for being with us today. Thank you everyone for joining today's session, and big thank you again for our speakers for such an insightful and hands-on demonstration. I think it was very interesting for most of our audience. You've shown us how to use the CLI tools, and your tool definitely does make decentralized deployments simpler and more efficient. And I'm sure that our audience today will walk away with a better understanding of how to put these tools into action. Thank you again, everyone, for participation. It's great to see the community learning and growing together, especially with our good friends Dima and Vladimir. You are, guys, automatically invited to our community day. I hope you remember that we have an annual event in the mid of the June. We are really hoping to see you there. So we will arrange another sessions somewhere at the mid of the June. And as we head into the holiday season, I want to wish everyone a joyful and restful time with their friends and their family, especially to you guys, Dima, Vlad. And let's keep building, let's keep learning, and let us know if there's anything that we could help you with our resources and our network. I hope with joint efforts we can do some good collaborations. And again, if you have some closing comments, go ahead. And everyone, take care and have a great day.
Yeah, thank you for your time. Thank you for joining. If you will have a question, came to us, and I think under the video, under the record, you can find all our contacts. If you will have some questions, ideas, please came to us. We are open for any new collaborations and so on. Thank you for your time.
Okay, see you guys.